Okay, so now we're going to talk about security insights, particularly with risks in JSON handling. So I want this demo to help you understand how improperly handled JSON data could lead to security vulnerabilities, um, particularly when developers just trust blindly unvalidated data or misuse Python functions. For example, the eval function, which I'll explain in a second, or deserialize unsafely. And remember, deserializing is the process of taking JSON to Python. Um, so why am I teaching you about this stuff? I don't want to teach you how to attack systems. This is about how to protect them. So I'm trying to teach you about risky coding practices like that eval function, and insecure deserialization, which we'll talk about pickles, so that you can recognize common vulnerabilities in code and understand how attackers could exploit them. And I also want you to learn how to write secure code that protects users and their systems. Um, so as you know, as cybersecurity majors, some of you, and just tech people in general, you understand that poor security choices can lead to loss of data, system breaches, financial and legal issues, and the compromising of privacy and safety of people. So I want to teach you how to be the person who finds and fixes these issues, and not the person that creates them, which I don't think any of you are, but I just feel like I need to put this disclaimer here because I am showing you something that is real bad. So we are going to proceed with extreme caution, and I I swear to God, do not run this in real life on your computer, in anyone's computer ever. This basically just bricks. If this executes, this will brick your computer, and that's not good. So, um, I want to talk about this. Um, Basically, it removes all of the essential system folders and processing, um, if it runs, and that is bad. Um, so the loads function itself is fine because it only reads the data from the JSON context into a standard Python type. But when you start using this eval function, uh, you start getting into some insecure territory. So eval takes a string and evaluates it as Python code. And if a attacker controls the input, like controls the value of the string that is given to this eval function, they can run code that deletes files, uploads malware, opens reverse shells. So this is what actually runs the system command. Um, Even though this here is being loaded, as uh, into Python code, um, with the loads function, that is okay. That's fine. Um, we're getting a print statement that'll say it's potentially malicious, but this line here will actually execute this, and this is what deletes everything and breaks your system. So, um, another few dangerous functions to be careful with are the exec exec, that executes dynamic code blocks, which we're not really going to talk about. These are just things for you to file away in your memory if you see them in future code. Um, we will talk about pickles. So one of the dangerous functions is pickle, like pickle dot load, and that deserializes Python objects and can run arbitrary code. And then YAML dot load is an unsafe mode, and it can instantiate arbitrary harmful Python objects. So just keep those in mind. Um, File them away for future retrieval. Um, but um, I'm going to comment this out because it scares the bejesus out of me that it's just hanging out there. Okay, so we're safe. Notice I put this in the safe malicious demo.py, LOL. Um, I'm deleting this. You saw that? Don't don't do this. It's bad. It's bad for you. I'm getting rid of it. This, the rest of this script is safe. It is a demonstration of a simulated malicious input where we're loading that simulated JSON script, and then we are going to simulate running it. So instead of actually executing it, we're simulating detection. So I'll run this and show you what like all the print statements are, but nothing will happen. Nothing bad will happen to my computer. Um, so it printed, there's a warning, suspicious action is detected. It prints the username associated with that data, and then the requested action as well, which has that string that, if actually executed, would heck up your computer. Um, so then here is the safe demo. So if the OS is in the data, and the remove references is in the action, then we're going to print that this input attempts to run a destructive shell command. And then also prints, this is a simulation, no action was executed, so don't freak out. So that is what was printed. Um, Nothing bad actually happened. This is just a simulation of detecting something like this. So that is the safe malicious demo. Um, and next, I'm going to talk about some best practices. Okay, so now we're going to talk about best practices with validation and sanitization of your JSON. So one of the things that you can do is whitelist expected data types and values. Um, so in this script, we're reading in this untrusted input that has not been validated yet. It's got two keys and a value per key for a guest, and they want to be able to log out. We are loading that into a data variable, and then we're going to validate the input. So we're saying our allowed actions are log in, log out, reset password. So if any of the values associated with the key action are log in, log out, or reset password, then we're Gucci. Otherwise, it's an invalid action that was requested and nothing happens. So we check if the data variable under the action key is if the value there is in this list here, log in, log out, or reset password, then we will print that this action, a valid action was requested, and then we can choose to, from here, we could choose to take that action, like call a function associated with logging in or logging out or resetting the password. And then otherwise, we'll say that the invalid action was requested. Um, Another thing, that is a better practice is to avoid the eval and exec functions entirely in code that is in production. So that is actually in use by customers, clients in your company. Um, so if you must use dynamic behavior, you might want to look into AST literal eval. It's a safer alternative that only um, allows Python like string literals. I'm gonna write that out for you guys. Peanuts. This cursed tablet. Oh my God. Okay, AST dot literal eval. That's an underscore, friends. Um, Parentheses. So if you want to look further into um, how to work with dynamic behavior safely, look this up, and it's a just a safer alternative for you. Um, but we're not gonna really worry about that. And then lastly, we want to never deserialize untrusted input. So we never want to just assume that some JSON file is all good and fine. Um, so that could be using pickle or that YAML.load. That's the YAML dot load, um, or any other similar functions, unless you are fully in control of that JSON source. So um, that is something to keep in mind. Um, Let me see. Um, oh, as far as input sanitization goes, we want to remove or escape harmful characters, and normalize spring, normalize spring. Please bring this on back. Normalize strings to remove Unicode exploits. Um, and we also want to validate the lengths, formats, using regex, which you learned a few weeks ago, or type constraints. So using the type function to check input, from files. Um, so let me go here. And I think that's all I want to talk about for best practices. Right now we'll be doing an activity in class related to this on Wednesday. But next I want to talk about analyzing JSON files, particularly like a server log example. So that is next.